Okay, differentiate y equals the square root of secant of x squared. This might be bordering on unreasonable, but we have two functions trapped inside of a square root function. So maybe we should start to write this, get rid of our square root. Of course, switch that to a power of a half. Start to prepare ourselves for our power rule. And then in here, of course, we have secant of x squared. So our outermost function is our square root, and our innermost function is x squared. And of course, we have our intermediary there, secant x. So maybe we should color code this as well. We'll say y equals, there's my power of a half, my square root, and inside here we have secant. And trapped inside that secant, basic quadratic. So, chain rule, we got to apply it twice, as you will see. Leibniz notation, I don't think we'll bother. We'll just say y prime equals, differentiate your outermost function first, which of course is our power of a half, using our power rule. And then subtract 1 from that power of a half, you get negative a half. And then rewrite the inner function, and I guess we should keep that separate, color wise separate there, which will slow me down. If I'm annoying you, you can of course fast forward, which is the beauty of technology. You don't have that luxury in class, unfortunately. Okay, so we got our outermost function differentiated. Now we got to deal with the mess that was inside, so we have to differentiate secant of x squared. Okay, so of course we're differentiating secant, basically. And since we're done with that first part, let's just switch this all to orange at this point. I already took the derivative of the square root, so that's a half secant x squared to the power of negative a half. Okay, now in blue we're turning our attention to secant, and the derivative of secant, if you remember, and maybe we should tuck that up here, derivative of secant of x was secant x tan x. So of course we need that fact here. So when I differentiate this secant function, it's going to go secant followed by a tangent with that stuff trapped, that stuff of course being our quadratic. Instead of x, instead of secant x tan x, we have secant x squared tan of x squared, and we have one more application of the chain rule, which is take the derivative of that innermost function, now x squared. Okay, and maybe we'll have a look at how we're going to write this. This is just going to switch into a 2x, and all that stuff can stay in the numerator. I think I'll move our negative power to the bottom, and since we started with a square root, we'll probably just write that as a square root. So our y prime, of course that 2 is in the denominator, so this is going to be 2 multiplied by the square root of secant x squared, switching my negative power to a positive power in the bottom, and of course switching it from a power of a half to a square root. And then our derivative of x squared will go right down in the front, which of course is 2x, and then write out our secant tan x mumbo jumbo to finish this off, and of course our x squared is trapped in there. And that's an intimidating looking mess, but we are finished. We differentiated the function, and there's our derivative.